Okay, welcome back to C#. So, what we've done so far is we've talked about a stopwatch application that was fairly rudimentary UI, and then we talked about a calculator application which had a little bit more in terms of UI, a lot more buttons, some styles, that kind of thing. Now what we're going to do is we're going to talk about the third application, which is a support ticket application in its most rudimentary form. So there'll be some follow-up kind of stretch things with this application like there have been with the other two, and that will be to add some additional functionality, but the main point of this application is to show you how to use multiple pages in UWP to implement dialogues and that kind of thing. So the purpose of this application is to allow a user to add a title and a description of a new support ticket to a grid. And by grid, I mean like a list box of scrolling tickets. So if we want to try this thing out, we should be able to do something like hook up my printer. My printer needs to be hooked up. So if I hit OK here, now I have in my list of support tickets, I need to hook up a printer and what the description is. I could have another one. So on and so forth. So I can select these things, and this is also the first time we're looking at kind of a what's called header detail view of something. So I have some details that are buried at this point in these. One of the stretch goals is to double click and then pop up the dialog with the title and description in it. But the details are inside of each of these header items, and then I have multiple header items. This is a very, very, very common use case in sort of business programming or creating data entry apps. So you have something like, I have a whole bunch of different accounts and I want to see all of the holdings or stocks in those accounts. Or I'll have classes and I need to see all of the students inside of the classes. So it's basically a one-to-many relationship that has a one-to-one relationship with details inside of each of the rows. So for the classroom example, for example, I could have a list of classes, and then inside of those, I would have a dialog that showed me all of the students, and then inside of each of those students, I would have a dialog that shows me all of their details, for example. So these things can go however deep you need them to go, but list boxes and data grids are very, very common ways to show this kind of data. So the other feature that we have in here is the ability to delete. So here I can delete and delete. I can add more. And if I hit cancel, it doesn't actually add anything. And so this is basically the absolute minimum feature set for a ticket application. So this is more similar to what you're going to be experiencing in the third programming assignment when you put a UI on top of your shopping cart. You're going to want essentially some buttons that will allow you to add things to a list. That list will be the things that are in the person's cart, and then you'll want a total somewhere displayed so the person can actually see what's going on. So without further ado, what we'll do is go through the code. So the good news is that the code here is much, much easier to explain, so you won't have to listen to me talk about code behind for 45 minutes. But there are some really, really important things to kind of cover. So the first thing is that this is the first time we've had two pages. So we'll talk about that in just a moment. The low-key new thing is that this is the first time that we've had a user input from the keyboard actually go back into the view model. So previously what we've done is we've always gone from the source, so from the property to the UI. Now what we're doing is going from the UI to the property and vice versa. So the first thing that you'll find is new is this guy right here, mode equals two-way. So what we are doing here is we're saying that there are actually three different types of modes. And if you hit enter, we'll show them to you. So one-time binding happens only when the constructor is called the very first time on the page. So what that means is if you're trying to build a dynamic label, for example, so if you have a banking application, you want to greet the user, you could certainly use one time to do that. Because you will know at render time who is logged into the app, and that should not change until the page is re-rendered. And if that's not the case, you have some pretty serious security issues anyway. One-way binding is the default, and that's what we've been using thus far. One-way binding goes from the property to the view. So things like the watch face of the stopwatch, things like the number display of the calculator, so on and so forth. So if you're trying to update the UI based on data that is changing on the other side of the application from the user, one way will work for that. Two-way binding also allows the user to change the property by virtue of manipulating the UI. So the number one, if not number one, maybe number two thing that you will run into the first couple of times using UWP that is extremely frustrating and may make you want to run headfirst through a brick wall is not setting the mode to two-way. If that happens, you will experience this. So I'll do that demonstration in a moment because it's easier to see. So this right here, two-way is on the list box. So this is also the first time we've ever seen list box, but this works exactly the same way as the text box. So here, instead of binding my text to a property, I've actually bound item source to a property, and that property is just a list of VeiwModels, and we'll go over that in just a moment. So in terms of the rest of the UI markup is not very hard. I've not applied any styles. I've essentially just kept everything the default. I have two buttons on the bottom, so there will be a stretch assignment to create a third button to edit, and so that could be an interesting kind of exercise to go through. But other than that, this kind of fits the bill in terms of what you would want to do with the UI. You might want to allow the user to reorder the list items, and you could do that by creating a data template inside of the list box, or you could create another series of buttons over here. The world is sort of your oyster with frameworks like this. As long as you know the basics, you can really make the UI however you want it to be. So one of the things that I want to do is get around to the ticket dialog. So we're looking at the main page right now, and so as you launch the application, this is the view that you're greeted with. So main page is what is being called from essentially the main method, if you want to think of it that way, of the UWP application. So this is the first page. When you click this add button, what's going to happen is you're actually going to create this thing. So the ticket dialog, if we look at dialog, has a text box that is the title, a text box that is the description, and these are bound using our standard kind of binding path to properties on a sub view model. So we have one view model that's the main view model, and then I have another view model that is a support ticket. This dialog is bound to individual support tickets, and then those feed back into the list that is part of the main view model. So if we close out of this, you will see that the preview here looks exactly like we were seeing when we actually created the dialog in the app. So how does that work? If we go back to main page, the code behind, you will see that I am using MVVM here because there are sort of bigger fish to fry in terms of stretch goals. So I've created a main view model, and I've bound that to be the data context for my main page. So when I click add new, what I'm going to do is I'm going to create a new page, and that new page is going to be type ticket dialog. So if I look at the ticket dialog XAML, and I look at the ticket dialog XAML CS, this is the constructor that is being called. So if you look at the code behind on main, you can see that I'm passing the whole list of support tickets from the main view model that is bound as the data context on this original page. And so this is the same type coercion that we've been using all along. And what this does is this allows us to make sure that we are always accessing the same main view model that is the data context of our application. And instead of calling the constructor over and over again, which would obviously reset the value of the support tickets. So this 2 lines of code here is what is actually performing the launch. And so if we look at main page XAML and we look at the button, we have a standard button click event. That standard button click event is wired to the code behind. That code behind literally just calls the constructor of our dialog class, and then we call the show async method on that dialog class. This show async is part of a context dialog. And so if you look over here, instead of being a page as a content dialog has base class as a base class is being overridden or derived by ticket dialog. And this base class is what has this show async method. So what this show async method is doing is it is allowing us to show that dialog. And if we need to do additional processing in the background, we can do that while the dialog is rendered. So if the dialog has maybe video associated with it, or if some crazy thing is happening in the background, this will happen on an additional thread asynchronously. And so this kind of harps back to our point about web services, which we're going to get into next. That where possible, you want to make sure that things are not done on your main processing thread. That's particularly important for thick clients, where if you are trying to run a bunch of business logic on the UI thread, your UI becomes not responsive anymore. So for example, if you wanted to show a dialog after the program factored two very large prime numbers, two prime numbers multiplied together, you wouldn't necessarily want the person to click add and then wait for 40 minutes before the dialog showed you those two integers. What you would want is you'd want to click add, do all of that stuff asynchronously, and then continue to work in the application as needed. So that's why this thing is asynchronous. And that's also why we've made our click event async, because it can be. And as long as we are async, we can use an await on this asynchronous call. And what will happen is everything will appear syntactically to be synchronous, but it will act asynchronous at runtime, which is what we want. So that is the kind of long and short of how to create the dialog and how to get the dialog to pop up. So that's the first kind of hard thing. If we look at the view model behind the page, it's actually being bound as the data context. We have a selected ticket, which is going to allow us to implement delete easier. It's also going to make your life easier if you want to implement the edit feature. So having a selected ticket is a very, very popular way of getting around trying to house a pointer on a view model that points to a list of things, which we have here, that is bound to a list box or a data grid or some other sort of one-to-many control. So instead of having an int or something, we can actually store a reference to that selected ticket, and that makes data binding much, much easier, and we'll actually see that in just a moment. So when we first create the main view model, it's important that we specify a default for all of the lists. So if you don't do this part right here, and you start trying to add or remove things from the list, then obviously you're going to have a problem. And so this makes sure that you don't run into null reference exceptions when you start adding your first item to the list, or when you start clicking delete when there's nothing there. So this will keep you from running into null reference exceptions that present crashing bugs that you definitely don't want in the end user experience. So the next thing is this observable collection. So what does this mean? What observable collection is it's a special flavor of list. So it has all the same bells and whistles that you've come to love and appreciate with list class, except this also automatically implements iNotify change. Here we don't have to have any iNotify change stuff happening in here. Notice we have implemented the interface and we have the event. We have an event handler for it, but we're not actually calling it anywhere. This is purely boilerplate code in case we need it in the future. We can actually delete this and everything would work fine. And the reason is because we're using observable collection. If we did not use observable collection, we could use a list, and then every time we add or remove things from the list, we could call that property change event, and then that is what would tell the list box out here to actually change. So here we don't necessarily have to do that for selected item or for item source, because this is an observable collection and that automatically updates the UI. That's the observable part of observable collection. You don't have to do that because it's by default managed for you. So the one bit of business logic that is here is the remove functionality, and what that is doing is if you go over here and you look at the selected item, we are two-way bound. That two-way binding allows the user to actually click and select the thing, and that will bind the selected item back to this selected item property, and then the remove click will call the remove method, and that remove method literally just goes to the support tickets and removes the referenced or the selected ticket. And so again, because this thing is a reference type, this is a reference, a public property that holds a reference, and we can use that reference to delete that specific item out of the support tickets list. This will become extremely important and very helpful for you as you do programming assignment 3. This is how I would implement the remove functionality going forward. So you don't have to do like all the kind of weird stuff that we did on the first two programming assignments. So if we go back to main page.cs, we do add new. The one part of this that seems kind of bizarre is add new is actually delegating the functionality of adding to the list of support tickets to the dialog. This is a design decision that at first seems extremely bizarre, but this is useful when you want to do test-driven development. So here what we're doing is we are passing the whole support tickets list to the dialog. This will allow us to perform unit testing on the ticket dialog because we will have access to the whole list. So while this feels backward, it's more useful for unit testing. So if we didn't have this, we would have to essentially cook up a list, pass the list into every method, instead of having access to the list in the class or the unit that we're actually trying to test. So here we can go to the ticket dialog itself. So the ticket dialog, again, is using support ticket as its data context. And we are passing in the full list as a private property or backing field in this case, because, well, it's not a backing field because it's not backing anything. It's just a private field. Because we don't necessarily want people to be able to access the full list from just the dialog. The access to the list is only because we want to be able to add the result of our new dialog to this list. So the good thing about the content dialog, which we look over here again, content dialog, is we get these primary and secondary button click events. The use case for these dialogs is almost universally that you want to have the user either answer a question or you want the user to provide details about one item that is going to go back to a list or is going to go back to a parent window. So what this does is it allows you to specify a null or a nothing secondary button click, and that is what cancel always is. So if you go back over here, we actually don't have anything in our secondary button click, but it behaves exactly as you would expect. So if we want, oh man, that doesn't make any sense, and we hit cancel, it doesn't do anything. That is because this allows us to do nothing. We're not adding, we're not deleting, we're not doing anything. And if you cancel and then come back, because I am creating a brand new dialog every time I hit that add button, I am calling the constructor on a support ticket. The constructor on a support ticket is blowing up all of the properties, so I don't have anything left over. So I'm not going to type test, for example, hit cancel, hit add, and then have test in my title again. So this support ticket dialog, what it's doing is it is essentially binding a new support ticket to the data context. That support ticket is then bound to each of these text boxes. And so I have a title and I have a description property. And if you go to support ticket, you will see the title and the description property. We will have a toString. This override is what's being called on the list box. So if I add title, title and description, and I hit OK, that hyphen comes from this toString. So that's what this is doing. So coming back over here, yeah, so that's really it. So I have two text boxes. Those are bound using the exact same kind of binding path that we've always seen, to something that is slightly more complicated. So the last bit are these dependency properties. So what the heck is a dependency property? A dependency property is a property that can manage its own sort of updates. So dependency objects are classes that have dependency properties, exactly like objects have regular properties. This is the dependency property pattern. What the dependency property pattern does is allows you to directly bind to a property and to delegate all of the update logic for binding to the dependency property. So dependency property doesn't require you to have INotifyPropertyChange implemented, because all of that stuff is handled for you as part of being a dependency property on a dependency object. So this is where we're going to start seeing the difference between a view model and a model. So a view model is really solely intended for binding. And so there's not a whole lot of difference between implementing INotifyPropertyChanged and implementing these dependency properties. A model itself is really intended to go into persistence, and that's a thing that we're going to start talking about in earnest, not next week, but the next. So what you can have is you can have these kinds of view models that sort of do both things. If you remember back to doing deserialization and serialization, what you can do is you can have these public properties, and you can mark those for deserialization or serialization, and you can have these dependency properties that don't get deserialized or serialized. They are only there for display purposes, and this more clearly differentiates the role of the property. These can be used for data management. These things are used for UI management, and that requires you to sort of serialize less information overall. So this, in our current context, really is just a different way of doing INotifyPropertyChanged. As we go forward and we start talking about MVC and the difference between models and view models, and we actually get into persistence, this stuff is going to become more helpful at that point. So what I would do if I was you is I would go through and I would really try to do the extension exercises for this application, because it is a more simplified version of what Project 3 is. And if you can do those stretch goals, then it is almost certain that you're starting off on a really good foot for trying to do your programming assignment number 3. So programming assignment number 3 is going to be due a week from today, which or tomorrow, which you can see is going to be not this first Monday, but the second Monday in November. And then we're essentially going to have assignments due every week until the last week of the semester. So what we're going to do is I'm going to make these extremely flexible, so you can miss one if you like, but if you start letting them pile up on you, it's going to be quite difficult for you to manage things. We'll have one due next week. You'll potentially have 2 weeks to do the next one, and then one final programming assignment due on the last day of classes. But I'll also, as we go through this last bit of content, I will make it very clear what the next step will be, so you can get a head start if you need to. So this marks kind of the end of our required sort of UWP viewing in order to do programming assignment number 3. The next thing that we'll do is we'll actually couple this UWP stuff with making a web call, which will allow us to build an application where we can make a web call and display all of the GitHub public repositories, or the top 1,000 public repositories from the GitHub API. So I hope that you find this useful. This is certainly the most utilitarian of the 3 projects. And this one is, if you've made it to this one, you can work through it. You're in a really good spot for building a UWP version of your shopping cart. So thank you very much for tuning in. Please let me know if you have any questions, comments, concerns, and I will also post a discussion board to help people stay on track for this next project. Thanks very much, and I will see you in the next one.